Hello viewers, welcome to my YouTube channel, and in this video I'll be covering some solved examples on the topic of basic definition and relationships related to soil mechanics. The first problem, which is presented over the screen, states that a sample of saturated clay weighs 15.45 Newton and has a moisture content of 38%. If the specific gravity of this sample is 2.7, we need to find void ratio, that is E, porosity N, dry unit weight, bulk unit weight, and the submerged unit weight for this given soil. It is to be noted that water content W and specific gravity is G is provided to us for solving this particular example. So first, since this soil sample is fully saturated, so for that fully saturated soil sample, the value of S is to be taken as 1. So we'll use one of the relation, that is W into G is equals to S into E. With this equation, we'll find out the value of void ratio. Now water content value provided to us is 0.38. It is provided in percentage. We'll be converting it in fraction. Specific gravity as 2.7. S value is 1, and the only unknown in this case will be E. So on solving, we'll get the value of void ratio as 1.026. We also know that porosity N is equal to E upon 1 plus E. So we'll substitute the value of E that has been obtained to us in this equation. And on solving, we'll get the value of porosity as 0.5084. So that is, if we express in percentage, comes out as 50.84%. Now, the dry unit weight, this can be found out using the expression gamma D is equals to G into gamma W upon 1 plus E. For finding the value of gamma D, I'll assume the value of gamma W, that is the unit weight of water, as 9.81 kilonewton per meter cube. So therefore, gamma D will be equal to 2.7 into 9.81 divided by 1 plus 1.026. On solving, we'll get the value for gamma D as 13.07 kilonewton per meter cube. We'll use another expression which states that gamma D is equal to gamma upon 1 plus W. So in this case, we have water content and also the dry density of the soil. So the only unknown will be the bulk unit weight gamma. So gamma will be equal to 13.07 into 1 plus 0.38. On solving, we get the value for the bulk density as 18.04 kilonewton per meter cube. Now, since the soil sample is fully saturated, we can say the bulk unit weight will be equal to the saturated unit weight. Now the last part is we have to find the submerged unit weight, which will be equal to gamma dash, that is gamma dash, that will be equal to gamma set minus gamma w. So gamma set is 18.04 and the value for the unit weight of water is 9.81. On solving, we'll get the value of submerged unit weight as 8.59 kilonewton per meter cube. So this is the solution for the first question. Moving to the next question, in which the natural soil mass having a bulk unit weight of 18 kilonewton per meter cube and water content of 8% is provided. Now, if the water content is raised from 8% to 18% in this case, so we have to find the amount of water required per cubic meter of soil to raise it, degree of saturation at this water content, okay, and we have to assume that the void ratio is constant. The value of G, that is specific gravity, is to be taken as 2.7. So in this case, firstly, we'll find out the dry unit weight of the soil. So this can be found out using the expression gamma upon 1 plus W, because bulk unit weight is provided to us. So this will be equal to gamma D will be equal to 18 divided by 1 plus 0.08. On solving, we'll get the value of dry density as 16.67 kilonewton per meter cube. Now once we have found out the dry density or dry unit weight, we'll also find out the value of void ratio, because that will be required for calculating the degree of saturation. So we know gamma D is equal to G into gamma W upon 1 plus E. We'll again assume the value of gamma W as 9.81. So therefore, E value will be equal to 2.7 into 9.81 divided by 16.67 minus 1. On solving, we'll get the value of E as 0.587. Now, we know from the definition, dry unit weight is equal to weight of soil solids to the total volume. We'll assume the total volume as 1 meter cube. So therefore, the weight of solid will be equal to 16.67 kilonewtons. So if what we know, the formula for water content is mass of water to the mass of soil solids. So we have two water content provided to us. One has 8% and another has 18%. So let MW1 be the mass of water when the water content was 8%. So that can be computed as W into MS. Here W value will be 0.08 and the mass of soil solids or weight of soil solids will be 16.67. So for the first condition, when water content was 8%, the mass of water comes out as 1.33 kilonewton. Similarly, when the water content was raised to 18%, the mass of water will be equal to 0.18 into 16.67. On solving, we'll get the value of mass of water corresponding to 18% moisture content as 3 kilonewton. So the amount of water required, okay, that is represented by mw. So this will be the difference in the mass of water in the two water content provided, that is 3 minus 1.33. So 1.67 kilonewton of water per cubic meter will be required to raise the water content from 8% to 18%. Now we have been asked also to find out the degree of saturation corresponding to the water content of 18%. So we have the value of W, we have the value of G. So we'll use the expression W into G is equals to S into E, and we'll find out the value of degree of saturation. Water content is 18%, degree of saturation is 2.7%, S is to be found out, and since void ratio is going to be constant, so we'll take the value of that as 0.587, that has been already found out. On solving, we'll get the value of S as 0.871 or 87.1%. So that's all from this video. If you have liked the video, hit the like button, share it with your friends, and subscribe to our YouTube channel for more such videos related to civil engineering. Thank you.